but it is a good entry to understand float times in general with the boxes. Here we go. Let's have a look at this question. This is VCA 2011, multiple choice with some dummies in there, okay? Now, they're asking you to find the critical path for the project. And the way I've been teaching you today is I'm saying find using Dijkstra's algorithm, but the reverse, find the longest pathway, yeah? So this is how I would do it. I would look at a starting point. I would say that from here to here, that adds to 4. There is no other point or any other way to get there. So 4 has to be the best time I can get for the end of A. From 4, though, I can get to the next point at the end of B. I can do 4 plus 3, which gives me 7. Or I can do 4 plus the 5, which is 9. 9 plus the 2 gives me 11. So clearly, 11 is bigger than 7. Okay, so clearly, to get to this point, there are 2 pathways that lead there. This is probably the longer pathway. So I would need to count 11 as my best time, okay, or the minimum time. Then from here, you can see that to get to point, the end of E, 11 plus 4 gives me 15. But interestingly enough, moving forward, F, 5 plus 7 gives me 12. And as a dummy, you can see that, oh, sorry, not 5 plus 7. It's 9 plus 7 gives me 16. Okay, so 9 plus the 7 gives me 16. And I can see that 16, because it's a dummy, it connects to point H, or starting of H, at 16. 16 is better than 15 that way. Okay, so notice that I circle the ones that are bigger. So here, I notice that to get to this point, 9 has to be the best value that I can get. So I'm going to circle 9 at that point there. So 9 going down is adding 9 plus 6 gives you now 15. Or again, the dummy takes me to 16 again. So 16 is the better route. Now, out of these 2 points, I've got 16 to get to the finish line. 16 plus 5 gives you 21. Or you could go from this route, 16 plus 3, which is 19. That's the best route that I can get to there. And then 19 plus 2 also gives me 21. But then notice from here, 16 plus 2 gives me 18 as the best route here. And 18 plus 4 gives me now 22. So out of all those 3 routes that connects to the finish line, so the 3 routes that connect to the finish line, I can either get 21, 22, or 21. 22 is clearly the time that I have to account for the most. So the minimum time required is 22. Therefore, the critical pathway had to be this. This is what I had to do to get to 22. So therefore, my critical path is starting with activity A, going to activity C, go to activity F, to activity, and F connects with L, L then connects with K. That will give me the minimum time required, which is 22. And so when they say the critical path for this project includes activities, which one of those have those letters that I need? And we can see D is the only one with F and K in them. That's my answer. So I'm not using the boxes. I'm not using what they teach you in the textbooks. It's much quicker, but it also identifies if I were to do crashing, which is this next exercise, what would I do to change so that the overall can be reduced? This is the pathway that I would need to reduce. Okay? All right. Let's do crashing now. Let's do crashing. So, exercise 15E, this is your last dot point of everything that you need to know. I will make more videos of this, but let's do the example they've got for your exercise. They've got a VCA 2007 question. The first few parts is quite similar to what I've been teaching you, and then it's the last part that is actually crashing. Okay, so here we go. Same thing. They say determine the minimum time in weeks to complete this project. How do you answer this question? Find the critical pathway. So we're going to do the same thing again, except this one should be easier now. Let's have a look. Starting from A, I can go up to this point at 4. I'd circle it as that's the best point distance for 4. 4 to D gives me now 5. 5 plus 3 gives me 8. Right? But to get to this point, I've got 2 pathways. So I need to work them all out. 4 plus 4 is 8. 8 plus 2 gives me 10. Or I could have done 4 plus 3, which is 7. 7 plus 4 is 11. 11 plus 2 is 13. So I can see 13 is the time that I have to account for. And then out of them all, clearly, 4, 7, 11, 13, 13 plus 6, that gives me 19. And remember they said here, these are in weeks. So that means my critical pathway I've identified, this is the longest time required. So my minimum time in weeks is 19 weeks. Can you see what I'm doing there? So the technique I'm using is Dijkstra's algorithm in the longest pathway. That allows me to identify that time. Okay, so we do the same thing. Determine the slack time in weeks for activity D. This goes back to your exercise 15D. Slack time is your float time. Activity D, where's activity D? Activity D is up here. You don't need the boxes to figure this one out. You can simply look at it and say, well, if the latest start time, so the earliest start time at this point is clearly 13, you got to work backwards. 13 minus the duration for activity G, that means the latest start time that D can finish, or start time for G, is 10. 10 minus the duration of 1, that gives me 9. That tells me that D can start at 9 and still finish at 10. 10 plus the duration of 3 will still finish at 13 in time. Because the deadline at this critical pathway, the deadline for activity I was 13. So as long as all of them meet by 13, it's okay. But to work out the slack time, now I know latest start time is 10, so end time is 10. Latest start time for D is 9. What's the earliest start time? You start at 0 and you can add 4. Latest start time, earliest start time is 4. So there's a float time for activity D. There's 5 minutes. They can either start right at 4 or they can start at 9 and then still finish the process in time. So the float time here must be then 9 minus 4, which is 5. Okay, so that's 5 weeks. But you can see I'm not using the boxes. I'm using the critical path to work backwards to find out my float times. And that's how I want you to learn it. That's not how the textbook teaches you, but I'm using a bit of intuition here that I knew this is the end point. 13 was key. 13, everyone had to finish by this point at 13, because if they don't, that delays the overall time. So 13 was key, and I just worked backwards. If that takes 3 minutes to finish G, 13 take away 3 gives me 10. That means the latest start time for D to finish has to be then 10 take away 1 is 9. If I work backwards even further, 9 take away 4 gives me now 5. So you can see slack time for A is 5 minutes. A doesn't have to start at 0. A can take 5 minutes later and still finish at 9. 9 plus 1 is 10. 10 plus 3 is 13, and everyone's happy. Okay, so this is the key part, that I'm not using the float boxes to figure it out. I'm using the critical part. Okay? Now, let's apply now. Write down the critical path. We already have it. It is B, E, F, H, and I as critical path. Now, this is where you're starting to work towards what we call crashing. Exercise here says, the builder of the community center are able to speed up the project. So we're changing the overall time. It takes 19 minutes to complete. 19 weeks. Says some of the activities can be reduced, and the ones that we want to reduce are A, C, E, F, and G. Let's highlight in our graph which ones are A, C, E, F, and G. So I'm going to highlight with a different color to help you. A, C, E, F, and G. What we know is that if you want to reduce the overall time, there's no point reducing the non-critical pathways. Okay, because they don't affect the overall time. What affects the overall time is the critical pathway. So already I can see that I probably want to reduce C and F to reduce the overall time. As soon as I reduce, say, C by 1, that changes 19 to 18. That's the idea. Okay, whereas if I change this guy here, it doesn't matter. Even if I made him 1, it still doesn't change the fact that I still need 13 minutes overall. That's why we're saying, try to change the ones that are on a critical path. So, Answering the question, which of these activities, if reduced in time individually, would not result in an earlier completion of project? I can already see A, E, and G. Those activities have no effect. Looking at the next part of the question, this is where you're starting to use crashing. So this is where the budget and money comes in. So let's have a look at this part. So for those who are starting to understand critical path, this is what makes 15E 15E. Okay? So here we go. 15E says the owner of the estate is prepared to pay additional cost to achieve early completion. So they want to finish the task earlier, but they have a budget. This is what their budget is. The cost of reducing time of each activity is $5,000 per week. So every week you reduce, it costs $5,000 to do that. Now, obviously, what they want is they want to maximize the amount of reduction in time. So instead of taking 19 weeks, what's the maximum number of weeks you can reduce at the same time keeping this a minimum value? Okay, you don't want to be wasting money. You don't want to be reducing certain activities and it doesn't change anything. So for example, if I just went over here and said, I'll reduce you by 1. See, if I reduce G by 1 week, it doesn't matter. The overall result is still going to be 13 weeks and I still end up at 19. So I paid $5,000 for nothing. I paid $5,000 reduce activity G, yet overall, I'm still getting the same result of 19. So what they're asking is, which one of these activities and by how much should you reduce so that you get the maximum reduction? So instead of 19 weeks, can I get 18? Can I do better than that? Can I get 17? Can I get 16, 15, or 14? And what's the cost? Because I don't want to blow my budget either. Okay, what's the best amount of cost for bang for buck? So how do you solve this? This is where intuition comes in. So let's have a look here, yeah? Determine the minimum time in weeks for the project to be completed now that certain activities can be reduced in time. Then determine the minimum additional cost of completing this. So this is how you do it. Let's have a look. This is where you use a bit of intuition here. So I'm just going to highlight again. We knew G, E has little effect. What makes effect is you either change C or you change F. Those were the only letters that you can change. Now, if I reduce C, so this is a hypothetical. When you do this, there is no method besides the fact that you have to trial and error here. So this is what I would have done. I said, all right, C is a critical path. If I reduce it by 1, right, the overall pathway, let's have a look. 4 plus 2 now gives me 6 here. 6 plus 4 gives me 10. Now, what's important is this point right here. That's really important there because that has 2 connections. If I reduce this by 1, I get down to 10. But what about this one? This was 4 plus 4 gives me 8. So I'm going to write 8 on this pathway. That means that I can reduce C maybe by an extra 1 until I get towards 8 before this becomes the new critical path. See, if I say reduce 3, so reduce C down to 1, this now becomes 4 plus 1, which is 5. 5 plus 4 is still 9. That's still a critical path from here. That's still a critical pathway. Okay? Now, what you can see is that as I'm going through this, I need to be careful because if I take too much off F and C, this becomes the new critical pathway and I need to get the most efficient and bang for buck. Okay, so here we go. Let's have a think. On the up hand, 4 plus 1 was 5. 5 plus 3 is 8. That was the value that I can get to. And 8 plus 6 gives me a total of 14. Okay? Now, the ones that I can reduce, if I reduce C by 2, hypothetically, and remember I can reduce F as well, so if I reduce F by 2, hypothetically, what's my overall result right now? Let's think about it. 4, 2, 6. 6 plus 2 is now 8. Now if I got 8, this is interesting because if that's 8, and this is also 8, this now becomes also a critical pathway. Meaning that neither of these 3 activities, E, F, and C, can screw up. Because they all only have 8 minutes to get to this point. Then they have 10 minutes to complete their work. So 8 plus 10 is 18. 18, sorry, is that right? 4, 8 plus 2 is 10. 10 plus 6 is 16. So far, if I did that, I'm finishing at 16 weeks. So I've been able to reduce 3 hours so far. This is great. But if I did that, let's have a look. This is also 8 as well. Think about it. 4 plus 1 is 5. 5 plus 3 is also 8. So I now have 16. It seems like my best one, but can I still reduce anything else that makes sure that I can still reduce and finish on time? Okay? So what would you do? And here you can try again. And this is what I mean why crashing is hard to teach, because it's quite intuitive, isn't it?